Hey guys, Gravity Max here. Today's video is co-voiced by my friend Sebi.
Hello.
Anyways, this video is about the smallest thing, as you might have guessed from the title. Anyways, let's get right into it. In science, everything is made of something smaller, and that something smaller is made of something even smaller. Is there a smallest thing? Yes, but before I talk about it, I want to talk about the history of smallest things.
We begin in ancient Greece with the philosophy of atomism. Atomism was the belief that if you cut matter smaller and smaller, there will eventually be a piece that can't be cut. This was referred to as an atom. Of course, the atomists had no idea what the properties of atoms were, but they believed they existed.
In 1803, John Dalton looked at chemical reactions and how every reaction gave out specific amounts of elements. Based on this, he proposed his atomic theory. 1. Everything is composed of atoms, which are the indivisible building blocks of matter and cannot be destroyed. All atoms of an element are identical. The atoms of different elements vary in size and mass. Compounds are produced through different whole number combinations of atoms. And finally, chemical reactions are rearrangements of atoms. Dalton's theory had some truths and some falsehoods. Dalton's model of the atom was solid spheres.
By the end of the century, 1897, a new discovery was made, the electron. J. Thompson did an experiment with a cathode ray. By using positive and negative charges and magnets, he found that the cathode ray was made of tiny negative particles. He called them electrons. Since electrons were smaller than atoms, Thompson concluded that electrons were part of the atom. With this theory, Thompson came up with the plum pudding model of the atom. This model was a positive sphere with tiny electrons inside of it.
In 1911, the plum pudding model was tested. Ernest Rutherford and his colleagues shot small alpha particles at gold foil a few atoms thick. What they expected was that the alpha particles would go right through in accordance to the plum pudding model. Many alpha particles did, but some were deflected in random directions. Rutherford concluded that the atom must be mostly empty space, with a hard nucleus in the middle. This is how he came up with the model of the atom that is a rudimentary version of the one that most people know today. The model with negative electrons orbiting a positive nucleus.
Since different atoms had different weights, scientists came up with the idea of protons. They thought that nuclei were made of one or more protons. In 1920, Rutherford postulated the neutron. This was because many elements had more weight than the weight of all protons they would have. It took until 1930 for experiments to prove it. James Chadwick did an experiment where beryllium got shot with alpha particles and let off a mysterious ray. He tried to measure the charge, but it was chargeless. Chadwick put a material rich with protons in front of the ray. He measured the motion of the protons and calculated the weight of the chargeless neutron.
In the 1960s, quarks were hypothesized. They were hypothesized to be the things that made up hadrons, particles similar to protons and neutrons that aren't very common. At first, up, down, and charm quarks were hypothesized. Then, more came along. This is how we got the more familiar particles. Two up quarks and a down quark come together to form a proton. Two down quarks and an up quark form a neutron, and electrons are elementary particles. Although these particles are most common, more exist. Charm and top quarks are similar to up quarks. Strange and bottom quarks are similar to down quarks. Muons and taus are negative particles that are heavier than electrons. There are also neutrinos, particles with no mass, no charge, and barely interact with matter.
Another part of the standard model is bosons. Bosons are particles that carry the fundamental forces. First is the gluon. The gluon carries the strong force. The strong force makes quarks form hadrons, and it allows neutrons to keep the protons from repelling each other and leaving the nucleus. The photon is the light particle, but it also carries electromagnetism. Charged particles emit photons that tell other charged particles to repel or attract. W and Z bosons mediate the weak force. The weak force is way too complicated for me to explain in this video, though. Finally is the recently discovered Higgs boson. The Higgs boson gives particles mass, so it carries gravity.
Overall, the Standard Model is very interesting. Additions can be made to it any time. We might find out tomorrow that a long and short quark exist, or a phi and phi neutrino, maybe even another fundamental force. Nobody knows. Also, similar to the atom, then the proton and neutron, leptons and quarks might be made of smaller things. Particle physics is very exciting.
If you have a question about science, leave it in the comments. Max might answer it in the comments, or Max might make a video about it. I hope you tune in next time for more scientific knowledge.